Hello everyone, allow me to introduce myself. I'm Khairunnisa from Building Engineering Education 11 Maret University, Surakarta. And now I'd like to present about my paper. The title is Study on Setting non-ferrous-based Geopolymer Mortar as Material Patch Repair with Variations of Water-Binder Ratio and Molarity of Sodium Hydroxide. So let me start with the first point. Introduction. Over time, buildings made of concrete will inevitably experience various kinds of damage. Method of repairing concrete is patching by mortar. Technology geopolymer has potential as a material for patch repair. Glass-based geopolymer mortar has as material patch repair with variations of water-binder ratio and molarity of sodium hydroxide. The second is theoretical foundation. There is a geopolymer mortar. The definition of mortar, according to Indonesian National Standard Number 3, 6825 on 2002. Meanwhile, geopolymer mortar is a mortar containing a binder that is free from the use of cement, but is replaced with materials high alumina and silica content, one of which is PAS. PAS, according to Indonesian National Standard 2460 on 2014, is defined as a fine residue resulting from burning or pulverizing coal and transported by hot air flow. And the activator is an element or substance that causes another element to react. The activators used in the manufacture of geopolymers are hydrated alkali elements, including sodium hydroxide and sodium silicate. And then the setting time is when cement or glass that has been mixed with water or activated solution will experience binding, and after binding then hardens. In cement, the binding is due to the hydration process, while in geopolymers, this binding occurs due to the polymerization reaction that occurs between glass and alkali activated solution. The third is research methodology. This study uses experimental research method where researchers conduct experiments directly in the laboratory to obtain data. The analysis used descriptive statistics. The test object used in this study was in the form of geopolymer with a variation of the water-binder ratio and the variation of the molarity sodium hydroxide. The tests were carried out by Indonesian National Standard 2000, number 3, 6827 on 2003. And then the result and discussion. The first one is for us inspection. Based on inspection result, the PAS is classified as a type C. And then for the result of initial and final setting time, from this graph, we know that the use of variations in the water-binder ratio and sodium hydroxide molarity greatly affects the resulting of setting time. The higher of water-binder ratio makes the setting time longer. This can be caused by the addition of water. It can weaken the polymerization reaction itself, so that the setting time will be longer. In addition, physically, the depth on geopolymer is also getting more liquid or watery, so the time it takes to harden is getting longer. And then the higher of sodium hydroxide molarity concentration makes the setting time longer. This condition can be caused by increase in the high concentration of sodium hydroxide, which has better solubility of silica and alumina, but it can cause the reaction that occurs in calcium to be inhibited. And the amount of calcium of high level in PAS is also limited. According to Khairunnisa, on 2018. This is in the research conducted by Komarudin on 2019, which studied that the higher of molarity used, the longer the setting time required by Geopolymer has. And then conclusion. In conclusion, let me sum up the main points. Number one is variations in the water-beaner ratio greatly affects the volume setting time whereas best Geopolymer Mortar, but the higher of water-beaner ratio makes the setting time longer. And second, the variation of sodium hydroxide molarity is very influential on the value of setting time whereas best Geopolymer Mortar, where the higher of molarity concentration sodium hydroxide makes the setting time longer. And therefore, variations in the water-beaner ratio and sodium hydroxide molarity in pH-based Geopolymer Mortar, which have a time between 45 until 420 minutes occur in the use of a variation of the water-beaner ratio in 0.225, 0.25, 0.275, and 0.3 with a molarity of 10 and molarity ratio of 0.2, 0.225, 0.25, and 0.275 with a molarity of 12. Meanwhile, the fastest initial and final setting time occurred in the use of operation of the air builder 0.25 with a molarity of 8, which results in the initial and final setting times of 15 minutes and 30 minutes, respectively. Thank you.